maximize this a little bit. We also talked about the different types of cloud services. We talked about benefits. That was all done last week. We didn't get to do a demo. Hopefully we'll do it after the break today. And we did not get to talk about the core architecture. So core architecture, think about your house. You know, the architect has to draw the plan of the house to say the kitchen will be here, the room will be there, and so on. So we're going to look at that today. And we'll probably take the first half of the class to do that. And then we'll also use time to look at Azure Compute. The three main services of Azure, as we pointed out, are compute, networking, and storage. So we'll start with compute today. Tomorrow we'll talk about networking. And then finally, Monday, we'll talk about storage. So that next week, we're going to talk about security, which has to do with identity access and management is also going to be done, which has to do with cost management for the most part. And then we'll round up next week with GRC, which is governance, risk, and compliance. The final week, we'll talk about management, deployment, spending most of our time on the portal, and then also monitoring tools and health services. So that we'll use the end of next week to practice, and we're good to go. It should be good to take this exam and finish it just like that and get ready for April so that we move on to better and bigger things. So what questions do you have before we get started?
Yeah, I think I have a question. Like these cloud services with Azure is I know this is Microsoft. How is it different from AWS?
Very good, very good. So we did point that out earlier on the first class. There are major players in cloud services, right? So cloud services, I'm not sure, Egbert, can you remember what is cloud computing?
Cloud computing, as long as I can remember, is the oh man, really?
I put you on the spot. It's providing computer services, right?
Yes, to the internet.
Over the internet. So it's just the services that are being provided over the internet. So the major companies, you have Amazon Web Services, they have their computers all over the internet. They provide those services. That's known as AWS. Google also has their bunch of data centers all over the world. They provide those services. It's known as GCP, Google Cloud Platform. Microsoft also has theirs, and they provide their services, which is what we are working on, Azure Cloud Services. So here we want to know the fundamentals. Last week we talked about the basic stuff, the basic types, and then this week we're going to focus on Azure's particular one, which is their own architecture. It's different from Microsoft. It's different from Amazon AWS, which is also different from Google Cloud Services. But at the end of the day, all of those cloud services, whether it's Alibaba or Oracle, their goal is to provide you with these three main things. And the three main things that they provide is the computing power, the networking power, and the storage power. So all those three things are the main things that, depending on which company you want to associate yourself with. Does that answer your question?
Yes, thank you.
Awesome. Very good, very good.
Is IBM also a cloud platform?
Yes, IBM also has a platform. There are quite a lot of them there. I think there are about 20 major ones, but then it depends. Some of them, like we pointed out, offer infrastructure as a service, others offer platform as a service, others offer just software as a service. Does that answer your question?
Sure.
Awesome. What other questions do you have? Gilbert, you're on mute in case you're asking a question. All right. So let's take the next 5-10 minutes to do a quick recap on week one. Okay. So again, just to talk about the exam. The exam which we're preparing for is AZ 900. it's going to cost you about $99 or $100 to write the exam. It's going to measure 3 main domains. We have already covered the first domain, which is the cloud concepts, about 25% to 30%. This week, we're going to cover the second domain, which has to do with architecture and services. It's going to cover the bulk of it, which is 35 to 40%. Architecture, again, is going to tell you about the physical things that make up Azure and how you manage them. So physical infrastructure and management infrastructure. And the services, like I pointed out earlier, those 3 main services: compute services, networking services, and the storage services. Once we've taken care of these first 2 weeks, the third week, we start looking at security, management, governance. And then the final week, we'll do a little bit of review and recap, practice, and you're good to go. So again, it doesn't really score you over 100%. It has about 60 multiple choice questions to be done in, maybe 50 multiple choice questions to be done in 60 minutes. And I'll give you a lot of examples, a lot of questions, a lot of practice. So by the time you get to it, you must have tried at least 3 times so that you're comfortable. Those questions are basic. You already know the contents, no matter how they twist it. It's multiple choice. You easily get your 700 out of probably 1,000 or 1,200. So domain 1, we've covered it, all of it. As you can see, it's highlighted in green. We also did benefits of cloud service. I forgot to highlight that. So yeah, we're all done with that. With domain 1 now, we have to dive into domain 2, which is going to talk about architectural components. And then later on today as well, we'll do part of this. And finally, tomorrow we'll get to complete networking, and storage will be done on Monday. So week 1 recap, like I said, a few things about the language of computing. So we described a stable and dependable cloud computing and the ability for you to adapt to changes in resource demand and user base and application and so on. So looking at these words out here, if you feel comfortable, you can pick any word and give me a description of what you think it is. I can start with high availability. High availability makes sure that even if one system goes down, the other system is up and running because it's in a different region. So you can have your computers operating or your servers running on the East Coast and another one running on the West Coast. If there's a catastrophe in the East Coast, the one on the West Coast is still running, so your business is still up and running. Now, scalability has to do with, if you say you created a website that you want to target just Africans, and then it becomes very popular. Now it's targeting Africa and Europe. Now you have more people coming in. There's a lot of traffic. It's scalable because it can automatically reproduce and have you more servers to accommodate that traffic. We talked about 2 types of scalability. You can scale up and down, which is vertical. That's by increasing the size, maybe the size of the RAM or the size of the disk or the size of the storage per se. Or you can increase it horizontally, in and out, right? In that case, you're adding more instances of, say, the virtual machine or whichever resource. And we also talked about disaster recovery, okay? So if there's a, say, for one reason or another, something like Turkey, unfortunately, if we had servers in Turkey and they all went down during the earthquake, then the other servers are going to be able to back up, and you can also recover your data from there. Fault tolerance, the same thing. Elasticity, you can be able to expand and retract as you need. Agility is very important. Agility, again, has to do, like those who are into Scrum. Agile mindset means quick. So you can get your website up and running quickly. You can get your system up and running quickly. You don't have to go to the market to buy hardware and set it up, find somebody to come and configure it. And if it goes down and so on, if you have no lights, no power, and all whatnot. So those are the benefits of cloud computing. All right. So what questions do you have with the language of cloud computing so far?
When you look at scalability and elasticity, like they don't seem to be kind of competing or how they operate, because it all depends. I mean, it all seem to talk about how you could increase the size and reduce, retract and expand.
That is very true. They seem very, very similar. I personally think that way too. But again, scalability, remember, scalability has to do with scaling up and down, in and out. Elasticity is just that you can expand. For instance, if you look at on-premises network, having everything on your premises, you can be able to decide to have some on the cloud, so that if you run out of resources, you can go ahead and use the cloud resources and come back. So it's not really scaling in that case. It's always there available, but you just use what you need. But scalability, you get to pay only for what you use. So that's a very good question. I'll probably have to find a better way to clarify the difference between elasticity and scalability, but I don't think you'll see them side by side per se. It's because they're very, very similar if you look at elasticity and scalability.
And
Does that help?
scalability goes, oh, sorry, go ahead.
No, go ahead. You're saying scalability.
So it goes like to the direction of having that vertical and horizontal adjustments, right?
Yes. Yeah.
And the horizontal adjustment also kind of, I don't use the word synonym, but also applies to containerization, kind of.
Exactly. Yeah. Yeah. So again, scalability, elasticity, I think they're interchangeable. But scalability is being able to add and remove, right? Regardless of whether it's hardware or software. But elasticity is having that automaticness, or should I say automatically scaling up and down, not necessarily doing it manually. So the difference is just the level of automation per se. Does that make sense?
Okay. Yeah, it makes sense. Okay.
Yeah. So if you have to automatically go in and add, that's fine. But if you want it to be elastic, remember, think about wearing your elastic pants. It automatically adjusts to your waist size. But you can also wear a belt. The belt will be scalable because you can change the belt hole to be tighter or smaller or bigger and so on. That one you have to do it manually.
Oh, okay.
Make sense?
Yeah, makes sense.
Awesome. Very good question. So a few things we also talked about. We talked about economics in the cloud. Most people use the cloud because it's very affordable. It's cheap. Okay. So we described the cost of computing being consumer based. Back in the days when you use the phone, you have to buy how many minutes, or you buy how many text messages, you use it or you lose it, before you finally got to this pay as you go method that you only pay for resources that you use. So that's what the cloud is all about. So rather than you having capital expenditure, where you have to have upfront amount that you spend to either build a house or buy a car, you're instead renting the services. So operational expenses. Obviously, I cannot type correctly. So OpEx is what you actually do with cloud computing. You're just paying for the resources that you use. Okay, so CapEx means capital expenses. And operational expenses is OpEx. So again, think about either, having your own personal car that you buy, you put gas, you do maintenance, or just having to take a taxi or Uber or Lyft, and then you can decide which one is advantageous for you. So we also talked about service models, cloud types. Okay, the cloud types that we talked about included, infrastructure as a service, there you're just renting the hardware. Okay, they rent the hardware, you go ahead and configure, do whatever you need to do to it. You know, again, you might decide to have it on your premises, then it becomes private, which we'll talk about later. Or you can rent the platform. The platform includes the hardware and the operating system. So we'll talk a little bit about that as well today to figure out what the difference is between software, hardware, operating system. So operating system as the platform, because all your applications run on the operating system. So think about it as either infrastructure is having the land that you're going to buy. Operating system is buying somebody's house that they have already built and then getting to use it. And then software as a service is you're not buying the hardware, you're not buying or you're not renting the hardware and the software, you're just renting the space. You're just out there renting the apartment. You know, you can move on to another apartment and so on and so forth. So again, this is software that is being utilized. Again, in all cases, you are the one responsible for the data that you put there. You're the one responsible for the type of devices that are going to access it. You're also responsible for granting access. If you decide that, okay, I want person A, B, and C to have access to this, you go ahead and set them up. But the company, be it Amazon for AWS or Microsoft for Azure or Google for Google Cloud Service, they are the ones responsible for the hardware all the time. They're the ones that are going to be updating the hardware, you know, having patches done on it. You don't have to worry about maintenance of the hardware. That's all their job. Okay. Except if it's on premises. If it's on premises, then you have to be the one taking care of all the maintenance per se. Does that make sense? So I believe that's a yes. Finally, we talked about different types of cloud services. Again, cloud services is just somebody else has their servers. We are using it to do whatever we need to do, whether it's to compute or to use networking power or to store information. So if we have decided that we are the only ones that are going to stay in this compound, that means it's your private compound. You be your fence, nobody is coming in. You have the gate person and so on. But if you're renting in an apartment complex, you cannot say nobody can come into the apartment complex. In that case, that's a public cloud. You come into the apartment complex like a hostel or a hotel. You go into your room, but all of you are using the elevator. All of you are using the front desk. All of you are using the reservation services and so on. But you have your dedicated area that is for you. So that's public and so on. Hybrid is using both, right? Being able to have the private and the public cloud in conjunction and one another. Meanwhile, multi-cloud would be having multiple houses, or should I say multiple apartments that you're renting in complexes. Okay, so you're using both Amazon Web Service, and maybe you're using Google Cloud Service for machine learning, and you're using Amazon Web Service for files sharing, and maybe you're using Azure Cloud Services to host your website. So all three services, you're using it for different things that need to be done for your company. All right. So that's that. The next part we have to talk about is what we have to address today: core architecture components. So I encourage you to always go to the website. If you go to our website, you can click on events. From the events, the most recent event is session 4 today. But since we did not cover session 3, I'm going to use about 30 minutes to see if we can go through session 3. So session 3 is a little bit lower. I'm going to click on read more. That should take me to a dedicated page for session 3. On this page, you can always join the class by clicking on the blue button. and it points out the objectives, the things that we need to achieve today. The audience, obviously, you need to have some information about last week. What you need to do is click on curriculum. If you click on curriculum, you see the link to the lecture. So clicking on that link takes you to the lecture. From there, I'm going to expand it so that you can see the slide that we're using. So before we get started, what questions do you have?
So which topic did you cover?
That was a very lengthy recap of week one. Everybody is good with week one so far?
Because since I
Yeah.
wasn't on. So
Awesome. All right, so let's go